Uh, like in the last lecture, we discussed about the concept about a thin wire and also area as well as volume, and we also discussed about parallel axis theorem. I also and later on we talked about product of moment of inertia, and in that we mentioned that it is like if you have with respect to centroid. So most of the time, as I also mentioned while defining the product of inertia, like if the axis is symmetric in the center of the whole body, then your product of inertia that you can move. So today what we will do is we will look at some of the problems or the techniques through which you can try to find out the start with the area. So we can start with area, and after that we can apply the problems related with the thin wire and then area. For example, there are three different ways. Different ways of computing elemental and or I would say that this is differential equation. So what I mean is, let's say if you have to compute moment of inertia about, let's say, side, this side B, if this is your x-axis and this is your y, you have to compute, let's say, Ix. So first of all, what you have to really do is Ix is defined in general, it is defined as y squared into dA. But what is your dA? You have to define this particular x element. In that case, you can take element like, let's say, take an element which is located at distance y, take an element which is located at distance x, okay, and a small increment dx here and a small increment dy here. So what it will give you is a, and this dA is nothing but dx into dy. So this dA will be dx and dy, and this is what about x. If you try to find out moment of inertia, now if you have to find out moment of inertia I by, so I told that this is dA x squared, and these integrations have to be done over here. And similarly, if you have to find out the product of integration, then Ixy over A, right? And this will be x into y into t. So let's try to find out these from this particular. So let's take this small element. Okay. So if you are taking an element of this order, so what will be dA? dA is nothing but dx into dy. Now what you have to do, you have to substitute this one into Ix, y squared dx into dy. Okay. So you will have to first see that what you are going to fix. Let us fix y. So if you fix y, what will really happen is you are free to vary your x along this direction, right? X, and here y will be y will be fixed about this direction. If you take x as a fix, then y will vary from here to here. If you fix y, x will vary from here to here. It means that the value of x is varying from 0 to a, and y is varying from. So if you have to compute this moment of inertia ix, then this will be given by fixed y. So what will happen? Dx will vary from, right? And so this will be your dx, and then your y, which is y square into dy, that will vary from point of inertia. So if you do the integration, a, right, and if you do the integration 2 by 3, right, and here you can substitute your integration and this will be a by 2, right. So then this way you can find out your ix, which is given by a b cubed by as the moment of inertia about x-axis. Okay. Similarly, if you have to find out, let's say, the same I by taking this strip, this time we are going to take and which is your y, this is your x, and so in this case you can try to find your ix as again y square into dx, but in this case what is your y, right? So your d in this case will be a times dy, right? So since this is equal to a times dy, you can substitute it here, and this will be given by y square a times dy. So a can be taken y, and then again you will be getting 0 to this will be ultimately giving you a cube by 3 again. So even if you take element which is dx dy, area is dx into dy, or if you take this strip element which is dx into dy, you will be able to again calculate your ix. Now let's try to compute the same thing by taking third kind of element. So at a distance x, right? At a distance x, you are having, and what is this? This is your dx. Total is your d, right? So if you try to, and we have to compute again ix. Compute ix in this case. First of all, you will see that dA is nothing but your d times dx. So how you will define your ix? Ix is y squared ix. So first of all, you will have to find out, since you will have to find out x-axis, so ix, right? So dix. What will be dix? Just now computed the moment of inertia of this rectangular section about this axis is being given by what is the formula? AB cubed by 3. It means that in this case your B is the length which is perpendicular to your that axis about which you will have to take the moment of inertia, and this is the parallel dimension. So here, if you try to compare this particular thing, this what you will be getting. A over here is simply dx. Okay, so the formula that we are going to use is here a is nothing but dx and perpendicular distance is b, nothing but bq, right? Divided by. So this is what will be your dix, b cube dx by 3. Now if you have to compute the complete integration, then what you will have to find ix by integrating this dix over whole x. So x is going from substitute this particular thing dx related to a, and this will be c a b cube. Right? Okay. So you can see that. So you can see that, here we used, in this case, we used element which is, so our element in this case was, this is your x at x, this is your dy at dy, right? So in this case your d was dx into dy. This is method number 1. Method 1. So we got a b cube by 3. This was method number 2. So we got our, again IIX, which is equals to, and then there is a method number 3, in which our element is the vertical strip, and still we are. And if you try to find out your IY, again you will be getting similarly, your IY will be given by your IY will be, so IX over here is found as b cube by 3, right? So similarly you can find IY is equal to ba cube by 3. Now the question remains, what will be the value of IXY? Since the axis is here, you will not be really getting the formula for it. So let's try to apply that formula and see if it turns out to be the same. So what it says, so what will be our IXY? Okay. Sorry, so this is method 2, and the last part that I just wrote was method 3. Okay, in which we had this kind of element. So, anyways, I have written it. Alright, so now the question remains how to find out IXY. Okay, so what I told in the last time was, if we just look at the formula x of y, then this is nothing but ix bar y bar, okay, or let's say ix dash y dash plus x bar y bar and k. So it means that if this is your x and y, and this is your rectangle having side A and B like this. So what will be its centroid? Since it is a very centroid. This is your O. Let's call it as C. This we can call it O. So what will be this particular thing? Is your y bar. This one is your x bar. So here, obviously, x bar will be given by a by 2, y bar will be given by b by 2. Since this axis, which is nothing but x dash and y dash, which is located at x bar and y bar from this particular point is symmetric about these. Line is symmetric about this one, and this line is symmetric about this. Hence, your I, x dash and y dash will be given. Since the object is symmetric about the axis x dash and y dash. Okay. So your x dash is equal to 0, and simply your ixy will be nothing but what is x bar is a by 2, y bar b by 2, and a is a b. So this will be a square b square by 4. 5. However, ix dash I y dash this particular because of the symmetry. Okay, if you want to find out directly what is the how to really start with this kind of elements in, so you will see that method 1 for computing kind of for computing product of inertia. Method 2. In method 2, what we can do instead of applying the formula, we can take small element which is located over there, right? And then the centroid of this one is obviously y. This is your x, okay? Dx, and this is your dy. So your dA will be given by dx into dy, right? X-axis is your y. For ix1, ixy will be defined as into x1. What is your dA? xy, dA is nothing but dx into dy. So you can have an integration limit. Here d integration will be getting 0 to a. This is 0 to b, and this is 0 square b square by 4, and your xy turns out to be a square b square. Okay, this is how it works. So you can see that from both these methods, this two. So this is the fundamental approach, and this is based on the formula where you will first see that what is your ix dash and y dash, and then you can try to implement. So this is how you compute your ix, iy, and the product of inertia. So if we have to compute, let us say first I'll also explain very compute moment of inertia circular object. So example, mi for circular arc. If you are having an object which is like this, here this is your R1, this is your R2, alright? have to find out I of, let's say this is x and this is y, I of x and I of y and IXY. So how to find out this? So let's start with the fundamental formula. Let's take the small r at angle theta, and you by d theta angle, okay, and also dr distance. So this is r, and then there is a small r which is dr, and there is theta, and the small change in theta will be. So dA is nothing but r d theta dr, right? So here in this particular case, you will see that the area dA in this case is given by r d theta and dr. Now, if you have to find out the moment of inertia x, it means that you require to have this distance. So anyway, we are not going to take this other than the small distance. Assume that this particular point lies in the centroid of this particular differential element. So this one will be what? This, and we can say that, and this is this. Y can be written as r cos theta. Sorry, y can be written as r sin theta, and x can be written as r cos theta, right? So now if we have to define I of x, what we have to do? Y square and into dA, integration over area A. So your y will be, what is y? Y is nothing but this. It will be r square sin square theta. What is your dA? R d theta into dr, and we have to now integrate it over the area A. How your r is varying? R is varying from r1 to r2, and theta is varying from to pi by 2. Okay. So if you apply again here formula, r square 1 minus cos 2 theta, right, from r cube drn back to your theta. Theta is varying from 0 to pi. R from r1 to r2. What you are going to get? Ix will be given by pi by 2 minus 0. Cos is nothing but sine. So let's try r, sorry, r4 by 4, which is from r1 to r2, and this is 1 by 2, obviously. And then you have theta minus sine 2 theta by 2. So if you substitute this is the range, theta to pi by 2, what you will be getting? Sine of pi and sine of 0. Here you will be getting 1 by 8, r1 r2 4 minus r1 4, right, into pi by 2. It means that the formula that you are going to get is pi r2 4 minus r1 4 divided by 16. Okay, so your Ix will be given by pi R24 minus R14 divided by 16, and this is how you have to compute the moment of inertia with that arc, okay, which is, and similarly, since it is symmetric, that Iy will also be equals to R24 minus R14 divided by 16, right? Now, if we have to find out the product of inertia in this particular, what is our x and y? So, product of inertia will have to be found for this particular case as x, y, right? Integration over a. So, what is your x? X is nothing but r cos theta. Y is nothing but r sin theta. A is nothing but r d theta dr. And integration will be from r1 to r2 and r0 to pi by 2. So first of all, r cube, and you can take 1 by 2, this is sin 2 theta, right? Sin 2 theta, you will be getting sin 2 theta dr. This right here, theta, so that you can perform theta integration first. So theta integration will be about 0 to pi by 2. R1 to R2 pi by 2. Then R1 to R2. So this way R4 by 4, then 1 by 2 is there. That will vary from R1 to R2. Sin 2 theta will become minus cos 2 theta by 2 and 0 to pi by 2. I will give you what? Cos pi by 2 will be pi, which is 1, minus plus, so 1 by 2, so this will be just 1, okay? And so product of inertia will be R24 minus R14 by divided by 8, and yeah, so your xy in this case. So now again, to just know that here you will see that this axis and this axis. However, if you try to find out product of inertia for hemispherical objects, for example this one. So first of all, let me just summarize this. For the arc, this is the case, this is the case, and this is the case. Try to write down for the semicircle. Product of inertia IXY for semicircle. Since this one is symmetric about x-axis, so any of the axis, even if it is symmetric, its I will be 0. Quarter one, this was not. So you can again have IXY for semicircle, circular arc, and also for complete circular arc will give you is Ixy equals to 0. How you generally compute your moment of inertia and product of inertia for the given object.